Hello everyone, and welcome to today's SANS webcast, Introduction to Writing Nmap NSE Scripts. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Jon Gorenflo, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Jon.
All right, thank you, Carol. Welcome, thank you everybody for joining us today. Excited to get started talking about Nmap Scripting Engine and writing some scripts here. Quick intro to me. To give you a little bit better idea where I come from, kind of my background. I'm not a developer first, right? It's not necessarily something on the slides or anything like that, but I am a network guy, right? I got started with the Cisco Network Academy way back when I was in high school, and I have learned to kind of see the world through the OSI model. I don't know if that's good or bad, but it's the way I think. So when it came to like writing scripts and learning to program and those kinds of things, it is not exactly my forte. So keep in mind as I go through this, if you're a hardcore developer, you may not like the way I kind of present things at sometimes, right? But it's usually because I'm trying to break it down for me that don't come from that administration and more to do with security. And it was a year or two into that job before I finally kind of figured out that I was more of a security guy than I was a network administrator. So, you know, that's somewhere in the 2006 to 2008 time frame. Right? And SANS Certified Instructor, I teach 504, which is the Hacker Techniques and Incident Handling class, and I also teach the Sec 560, which is Network Penetration Testing and Ethical Hacking. Both those classes, we talk about the Nmap Scripting Engine. However, we just talk about using it and using the scripts and such that already exist. The purpose today is obviously to go a little bit further. One of the reasons I wanted to do this talk was that in my various experience as a pen tester, as managing a pen test team, now with my own company, doing security architecture, incident response, there are a million times that I needed to do a very broad check across the network and look for something that maybe I didn't have a plugin in my vulnerability scanner for, or there weren't existing Nmap scripts to help me do, or there wasn't a Metasploit module to assist in checking or identifying vulnerabilities and that kind of thing. So with those situations, you're stuck with either maybe breaking out Python or a simple shell script with some curl or something like that, who knows, to try and figure out what the to check those remote hosts. Being able to do it with Nmap gives us some benefits, right? And I'll kind of explain what some of those things are as we progress here. From my company, we focus on penetration testing and do offensive work of just about any kind, but that's not why you came, so we'll skip past that, right? Now, again, the purpose of the talk here is the fact that Nmap is everywhere. You don't always have the script or the module that you need in whatever tools at your disposal, and at some point you need to be able to validate all of those tools. So and part of any good vulnerability management program includes going through the process of validating the findings from our scanners, or maybe it's incident response or something like that, where you're just trying to validate that, you know, everything's been caught and cleaned up throughout the network, right? Being able to write some scripts and having a tool like Nmap that will take care of all of the sockets and all of the network level communication, and allowing you just to mess with or manipulate the input and output to and from the program across the network, speeds it up quite a bit for us. It makes it much easier for us to go from, you know, no script to be able to check remote hosts relatively simply, right? Now, one of the reasons I picked the module or the script I'm going to write today is the fact that examples already exist. Okay, when I'm trying to learn something new, and you know, obviously SANS is very much a learning institution, but I tend to pick something that I already know how to do, right? At least when I learn faster, right? If I pick something that I don't know how to do and try and learn 2 new things at once, I'm trying to solve a problem I don't know how to solve while learning a brand new language, that's like 2 conundrums at the same time. And I don't know if it's failing because I'm screwing up the language. Is it failing because I don't understand the problem I'm trying to solve, right? So I picked the Webmin backdoor here because there are checks already available in Metasploit. There are plugins and such available for Nessus, etc. However, there's some issues with some of that as well. So I configured a host with a vulnerable version of the Webmin on it, and then made sure I had the appropriate plugins in my Nessus scanner and scanned my host, and Nessus did not identify the vulnerability. I thought, well, maybe I just need to make some tweaks. I adjust the scanner, did some other things, and still, right? Without going like deep into troubleshooting on one specific vulnerability that I knew was there that Nessus wasn't saying was there, well, what are you going to do, right? So at this point, it's good to have that second check, right? There are Nmap modules available for exploiting this and scanning for this, and Nmap is great, or excuse me, Metasploit is great for all those things. However, if I want to scan a network and do it at scale, Nmap is the way to go. Right? So much so that we have the db_nmap option in Metasploit to make it easier to scan this stuff at scale. Right? So with that in mind, I could reference the code in Metasploit, see how they're doing their check. I can do my check in a similar fashion. It makes it easier for me to go learn the language, which is really what I'm trying to learn here. Right? And then the bonus here is I'm going to have an Nmap script at the end that I can use to look at the identify the Webmin backdoor. Okay. Now, I'm going to spend the vast majority of this webinar demoing the process of writing the script. Okay, because to do it any other way is, well, the title of the talk here is writing Nmap scripts, not slides about Nmap scripts, right? So we're going to try and focus on as much doing here as possible. Okay. Now, with anything that you tend to do in programming, we tend to start with a hello world script. Okay. When we look at the Nmap scripts that are available to us, there are 3 main components to the scripts in Nmap. Now, when we look at this, we have the head up here, and I've added comments here just to break these sections up. You won't usually see these in the actual Nmap scripts. We have the rules and the action. Right? So the head is kind of administrative information about the script. It's where we usually see the imports. You'll see inside the scripts that come with Nmap. Sometimes you'll see your imports for the libraries and that kind of stuff up here at the top. Other times you'll see it down here closer to the rules or something like that. I don't think there's a official way to do that. I haven't seen documentation saying one way or the other, but there's a mixture of what's out there. When we have a description, this is where we see kind of like doc strings and that kind of stuff. This is what shows up in the help information for the script. So whatever we put into the description here, if we did nmap --script--help and then the name of the script, it would print that out to the screen. So I'm just going to quickly enter in here. This is a hello world script. Okay. Very simple. Down here, we more doc strings. Okay, so we just add in some additional details about how to run the script and that kind of thing. Okay. And then we have the categories, the author, and the license. Now, license, obviously, we always have to have a license agreement of some sort, right? Author, you put that in there. You can put your Twitter handle, your email address. You can put whatever you want into that field. It's just so that people can find you and get a hold of you if you've published your script and they're having problems or they're curious about how something works. They want to make a suggestion, right? The categories piece here, really important. Now, if you've taken 504 or 560, or even if you haven't, when we scan with scripts with Nmap, there are certain categories for the scripts throughout. When Nmap scans, it will run specific categories of scripts by default. In fact, there's a category called default. You can see that in the script here. There's a category called safe. There's a category for intrusive and exploit, right? There's many different categories. This is where we specify the category for this specific script. Now, I just kind of created this real basic shell here so you could see kind of what this looked like. Okay? But the point of this here is that it is, this is where we specify those. Then we can, when we run those scripts, we can say -- script with Nmap and specify an entire category of scripts. So I could just run all of the default scripts, or I could run all of the safe scripts, okay? And this just makes sure that the script that we're writing ends up in the appropriate category once you update the database. Okay? Now, that's all just the basic information about the script, a little bit of detail. The most functional pieces here are the imports at the very top there, okay? The rest of this would probably work without those things, I think. Now, the rules piece. The rule is very important. There's different types of rules. There's a pre-rule, right? There's a host, and then the ports and services, and then there's post rules. Now, these rules specify what this script does and when it does it. Now, when Nmap runs these things, it's going to launch the script itself, and the NSE, for the Nmap Scripting Engine, is the Lua programming language. Now, Nmap is written in C, right, and C++, but it launches an instance of Lua and then lets you incorporate these scripts. Now, Lua was chosen because Lua specifically is focused on embedded like module or customizations, right? So it's usually an embedded language. So much so that, in fact, if you look at the script here, right, usually if you have a development background or experience writing scripts, there's usually a main function somewhere. And you notice that that is actually missing in our script. Right? We're not actually going to have a main function because what we're actually developing here is an individual script to be run as a part of the program itself. So there is no main. Now, conceptually, the action piece at the bottom here is kind of like main for the script. Right? However, it is going to run the port rule and such first. Right? So don't take that analogy too far. Now, when it gets down to these rules, the rules themselves are what define whether or not this script actually runs. So when we look at the rule, there's a few different ways you can do this. You can write all sorts of fancy Lua logic in here to get this port rule to trigger. And if it triggers or basically returns true, it says, hey, yeah, go ahead and run the script, then it goes in and takes the action specified below. So we have to have some sort of evaluation in this port rule so that it actually runs the script. Now, there's some options available to you. There is a library included with Nmap, and it is called the short port. Now, what short port does is it has a whole bunch of kind of pre-written rules and options for you in Lua so that you don't have to rewrite all these common means of determining whether or not you're going to run a script or not, okay? So once it determines that it's going to run the script, it then moves on into action. Okay? Now, looking at this, first thing we need to get set up here is the port rule. Okay, so this can be individual ports. It can be a table of services, which in Lua, a table is kind of like an array. Right? So we can provide protocols, the status of ports, right? All sorts of things. So real quick, just because I'm going to kind of use this to base on the as a base for the next script, we're just going to say port 10,000, and because that's the port that Webmin actually runs on. Okay. Now, we have the port service, port 10,000, but I also want it to trigger if it's running HTTP or HTTPS. Okay, so now if I do this and say HTTP, HTTPS, okay, so now those are both options available to it. And then we do, over here, we're going to do TCP and open because we want that port to be open. Okay. Now this is just a very simple rule. It's going to look at the remote host and see if those ports and such are open, and if so, then it actually goes through and runs the script. Now the script here, I'm going to do the simplest form of the script that I can, and again, this is the hello world, right? So I'm just going to return. Now what I return here is then what makes its way into the output or the results for Nmap. Now, I get access to that where I provide those results via the std NSE library. Okay, and then I can just format the output world from NSE. Oops. Very simple, and that's it. Okay, so very quickly save that, and then I can use Nmap -- script -help. I'm going to do a // here, and the reason I'm doing a / is I've saved this file to my desktop. Right? There's a large directory of around 600 Nmap scripts that are installed with Nmap, and by default, it's going to go to that directory. Because I have this stored on the desktop, I have to point directly to it. Right? And this is just an easy way to do that. Oops. Oh, there we go. Okay. Nice little typo. Really trying to avoid the whole copy paste. All right, so there we go. Very simple. Now it prints out, tells you the name of the script, gives us the categories of the script, right? And it gives us the license information, and then this is just that information that I put into the description. Right? Very simple. Now, that's the help. If I want to run this, though, and now I'm going to run this against a remote host. I have a host set up with a vulnerable installation and configuration of the Webmin backdoor that we mentioned before. And so that is on 2.168.0.101, and it is on port 10,000. Okay. Now, port 10,000 is in the top 1,000 ports for Nmap. So we wouldn't need to specify that by default because it would identify the port as being open because it's going to check those top 1,000 ports. I'm just going to specify the port here to keep the scan nice and fast. Okay? Then to call my script, I just do -- script, and then I point to the script. That's referenced here. Let me widen this out a little bit. There we go. Okay, and so then this should scan it, and you can see it identifies that port 10,000 is open. Okay, the host is live, and then it prints out from the name of the script, and then it indents and prints what we put as our hello world. All right, now very simple, very easy. Okay, now but what happens if I get rid of the 10,000 here? Notice that it didn't run my script. You may be asking, well, why? Well, because we didn't say specifically, hey, if this port is open, run the script. Okay, so to make it run it, if we don't necessarily know what port it's going to be running on, which an administrator could change the default port, we'd have to do a version scan, right? And so this takes just a little bit longer, so it's the only time I'm going to do it. But if I do the version scan, it's going to detect that HTTP or HTTPS is running. Okay, and so we've got it configured here in our script to get HTTP and HTTPS. Okay. So we should be able to go. As it does take a little bit longer, it's running through a bunch of different scripts as it does this. And so there are additional types of scripts you can do for service identification and that kind of stuff. And goes a bit beyond just the basics of what we're doing today, but I can do an additional talk or blog post about that later on if people are interested. And if you're ever stuck at Nmap and it's, oh, there we go. There. Okay, so now it ran through, it did the server head, it did identify that it was running. However, it didn't actually run the script. If I take those out. So as it runs there, the point that I'm trying to make here is that you can mix and match and change these things, and you can make this port rule a little bit more dynamic so that it doesn't get stuck to a specific port, right? To keep it simple though, the vast majority of the time you are going to find that this is running on port 10,000. That is the default. So I'm going to put all that stuff back in there. Still didn't do it. Well, we could go through and debug that, but I'm going to save the debug for the next script. Okay, so this is a very basic, just hello world. I can save that, make sure it's working again here before I. There we go, nice and simple. All right. If I want to get more detail about that, all I have to do to debug my script is add a -d to the very end. Okay, and then there's some debug options available to us, and I'll demo some of those in the coming script here. So I then hit run. Now, it happens just as fast there, and it looks the same. However, if we scroll up a little bit, notice all this additional output that happened when I ran the script. So here's my -d, right? It goes through and it kind of gives you an update as it progresses, step by step, what's going on with the script as it runs. Okay? Now, if I did this with, for example, with the -sv a minute ago, you would see it run each individual service identification script as it goes through. So you'd see like the finger script and that kind of stuff that's checking for those services. All right. Now, hello world is great. However, you know, we usually want to go a little bit beyond that, right? This is where we're going to get into the checking for the Webmin vulnerability. Okay. Now, this is kind of the shell of the script. I just kind of copied over what I had for the Webmin hello world. Okay. We're going to add more libraries here to get this to the point that it actually does what we need it to do. Right? But I'm going to try and add those as we go. Right? Now, if we look at this, I'm going to change this here because this one, technically, to do the check that we're going to do here, it's a relatively safe check, but I still wouldn't call it safe. Right? And I don't think that is something that should probably run by default. So I'm just going to get rid of these, and for now, I'm just going to call it intrusive. Right. We'll keep our port rule the same. That doesn't need to change. But at this point, we're going to begin making requests to the remote page. Now, some quick background on the Webmin backdoor that was referenced in the abstract for the talk. At DefCon last year, a researcher presented an issue that he identified with the Webmin package for, it's actually for almost every operating system at this point. Webmin, if you're not familiar, is a web-based administration portal for, or page for Unix and Linux and Windows and all that. You can create users, you can install packages, you can change logging settings, you can do just about anything you need to do administratively on a remote system through Webmin. The catch is, by default, Webmin runs as root. Right? Now that's usually not the best way to go in terms of running services and such on a computer, but that's the way it's configured because it does a lot of administrative things. Webmin has it's been around for quite a while, it has a history of various types of vulnerabilities over the years, but this one was pretty bad because it wasn't necessarily that the Webmin console had a vulnerability itself. It was that they had two places where their code base was. They had their code base in GitHub, and they had their code base out at SourceForge. Somebody compromised the code out at SourceForge and inserted a backdoor. And basically it allowed command injection, and it was saving copies of passwords and that kind of stuff. So it was fixed. They removed it. It took a little bit for them to figure out what, how that all went down. Interesting story if you want to take time to look that up. But the point is, if you installed Webmin from SourceForge from version, it was out there for I think well over a year or longer. It was like version 1.832, I think, something like that, through 1.930 is the first version that fixed the vulnerability. So if you installed it that way, there's a potential that you had this backdoor running on your systems. Okay. Now the issue in the vulnerability itself, if you post to the change password page, which is the password_change.cgi, you enter username, you enter old password and new passwords, and when you do so and press enter and go, you can actually inject additional commands in the old password field. Okay, and so we don't actually have to go visit the page to do that either. We don't even have to have a good password for a user. It would just work regardless. And because it was running as root, it would run whatever command we sent. Okay. So we'll start off by just trying to make a basic connection out to the site. So we're going to need to use the HTTP library in Nmap. So we're going to do local HTTP equals HTTP. Oops, don't want that. All right. Now down here in the action, this is where we're going to start doing things with the script. Okay, so one of the first things that we want to do here is we have to start defining some headers, because if, for example, if I, like this, I say curl, I'll just do it in the browser so you can see it. If I send a GET request to the vulnerable page, oops. If I send a GET request to the vulnerable page, password change.cgi. Yes, I know I don't trust the certificate. I end up here, and Webmin tries to be smart and warn you and says, hey, by the way, you just landed on this page to change your password, and I don't think you actually meant to do that. Right? Well, what Webmin's actually doing here is it's checking the referrer, which is a header field in the HTTP request. And if it doesn't have a referrer showing that it came from the Webmin server itself, then you end up on this page and your attack doesn't work. Now this happens because we sent a GET request to the site. Now if we send this via an HTTP post, that's a different story. So if we send the post and change the referrer, we end up with a, if we inject the referrer and change the referrer here, then we would end up at the appropriate page. However, we're not authenticated. With the post, it works whether you're authenticated or not in terms of running the extra command, even though we can't actually change a password because we're not authenticated. All right. So with our script, what we're going to do here is we've got to we're going to set up the request itself. Now, you'll notice that we keep using local here for variables and functions and that kind of stuff. We use local in Lua because if you don't type local before your functions or variables, etc., it ends up being a global variable or function. And you really don't want to do that unless you really know what you're doing, because it'll let you stomp on existing variables or existing functions if you pick a name that already exists, right? So highly recommend, unless you're very familiar with what you're doing, you stick to the local. So we're going to do local. We're going to call this response. And so this is just going to be the response of the HTTP request that we're going to send. Right? So we do the http.host. Now here we need to give it the host or the IP address, right? So we can do host name or IP address. I can hard code that in here, but I'm going to use variables here from the Nmap API so that it uses the individual IP address that was identified as having the port open and all that in the normal Nmap script. Okay, so here what I'm going to do is do host. Now host is actually a table or an array, and inside there's a bunch of it, so it's an object really. So inside there is the IP address as well. I'm going to do it by IP address. So host.ip, right? And I'm also going to do port. Now you'll notice that we have host is passed into the action function, right? And so is port. So I'm getting both those passed in from the action script as it's called. Next, we need to tell it the path of the page that we want to attack. All right, so this is going to be the password_change.cgi. All right, and then a couple other options at the end here. Now there's the options, which I'm going to call it options here. I'm going to create this variable in a second. This is going to be another table, right? You can ignore this. The nil is for a field that doesn't get used anymore, right? And then we have data, right? Now, data and options don't exist. We're going to create those here. So what's happening with this is we're going to do an HTTP post request to the individual host IP address on the port that was identified as having the HTTP and Webmin on it, right? We're going to go to the password_change.cgi page. We're going to pass it a table of options, right? Now, two things that we need to do to get this working for us here, okay? First, we need to create that options variable. Local options tools. And so in here, I'm going to create the table itself. And in there, I'm going to create another table called header. We'll just make it easier for us to add things to it. Okay, so we have a table and the header table inside it. Right? So that's the options that we need. And then to configure the header, I'm just going to do options header. And then from there, we're going to add the refer. Yes, I know that's spelled wrong. Don't complain to me, complain to the RFCs. All right, now we're going to set that equal to. There's more elegant ways to do this, but just for the sake of expediency here, I'm going to hard code this one. All right. Now, we could work on building the string and all that stuff to show you how to do that, but I want to get through to actually running the script here so you can see the full thing together before we get to the end of our time here. Right, now, that sets that refer, so this is going to eliminate the message we got back from the Webmin webpage saying, hey, by the way, you're coming from outside the application. This is going to make sure that our request is fully processed. Okay? The next thing that we need to do is, and this was, as I was learning this, was kind of frustrating. Oops. At first, when I wrote this, I could not get it to run. And the reason was that it wasn't running on HTTPS. So it would run, the script would come back, and I would see results in the page, and the page itself was giving a 200 message saying, hey, okay, everything works just fine. But it wasn't actually switching over and using HTTPS. But it would have a link in there saying, hey, by the way, you need to use HTTPS. But the request or the response to the request didn't include a location header or anything like that. And so Nmap was having trouble figuring out that it needed to do HTTPS. So what I learned was we can add to the scheme the HTTPS. Right? So we can just do options.scheme equals HTTPS, and that adds that in there. Now notice that I've added things to this table 2 different ways, all right? And neither way is right or wrong. You can do either one. You can either reference it or add things the way I did up here, or you can actually add things into the tables themselves when you initiate the variables, right? Or in this case, we just do the add scheme and then we add this in, okay? So we add that because it tells it, hey, use HTTPS. Even though you don't see anything, or even though you may not be able to figure out to use HTTPS, use it anyway, okay? And so it will then do all of the communication here over HTTPS. Next, we need some sort of a token, because what we want to do is inject a command, and the command we're going to inject here to do the simple check is simply an echo command. But we need some sort of unique token to look for in the results. And if we see that token pop out in the results, then we know that the command was actually executed because it's being echoed back out to the screen. Okay? And so what we end up doing here is I'm going to do a local variable, and we're going to call it token. Now, to make it a little bit easier to follow and keep this simpler, I'm going to do base 64 encoded hash of the host IP address and the date concatenated together. Believe it or not, like showing ASCII hex and all that stuff in Lua, not exactly the easiest thing in the world to do. I think I found somewhat convoluted things, and I thought it made the script a little bit more difficult to read. So I'm going to keep it a little bit simpler here. So we need some additional libraries, though, to get this working. All right, we've got the HTTP library included already. However, I'm going to need the URL library and the OpenSSL library as well. So I'm going to come back up to the top, do local URL equals acquire URL local SSL equals acquire SSL. So then I come down to here, and what I'm going to do is do a, oops, I forgot my base 64. Local base 64 equals require base 64. I'm going to do base 64.enc for encode, and then inside here, open SSL.md5 And here we're going to do the host.ip. And to concatenate strings in Lua, we can just do it with a dot dot, right? So that is an operator itself. Right? And then we'll do os.date. Okay, so that should run it when we do os.date, it produces the date, the time down to the second. It doesn't go to like microseconds or anything like that. But for the individual run, it should be different every single time that you run it. Okay. Now the os date, and then we need to start closing out our parentheses here. So we've got, should have 3 closes in a row there. All right. So what that'll do is produce a short little base64 encoded thing, and that's what we'll actually get as our result in a moment. Okay. Now, we've got our token, so we need to send this through as a payload, right? And so let me quickly do an example here of the attack itself. So I'm going to do the curl the HTTPS 2.168.0.1 password underscore CG password change.cg. All right. Now, what we're doing at this point with this is we're going to do the curl request, but we need to do it as a post, and we also need to set that refer. So what we need to do is do a -d for the a -d for the data and a -e for the refer. So we do -e, and for the refer, we're just going to do HTTPS 2.168.0.101 and then -d, and then we need the what it looks like to do the actual password change. Now I'm going to copy and paste this piece just because I'll screw it up because I'm trying to reference notes or anything like that. All right, now I'm going to get rid of that. And so in the original post about this, you notice that you'll have the old password, a bad pass, do a pipe, and then whatever command that you want to run. Okay, now just for demonstration purposes, I'm going to do the ID command, right? So we can see that it is running as root. Okay, and then it goes through to the rest here. Right. Yeah, it doesn't like the certificate, so I need to do a -k at the front. Okay, now we get a whole bunch of HTML back. But if we come up to here, it says, hey, by the way, failed to change your password. Your current password is incorrect. And then immediately after that, we see the results of the command. The ID command ran. It came back and said, hey, by the way, I'm running as root. And I'm in the group ID root. Right? So is actually running as root. We can see that it is vulnerable here. Okay. Now, running the ID command, something like that, pretty passive check. But to make this a little bit more passive, and this is the check that they run in the Metasploit module as well, we're going to do the same thing here, except we're going to have it echo the token that we just created. Okay. Now, as we do this, we're going to create a payload variable here. Now, I'm going to set it up this way just so that there's flexibility later on. Say local kind of payload equals. And what we're doing with this payload is we're going to URL escape the token and the command that we're going to run. Okay, so we're going to do URL dot escape. I'm going to paste in the payload that I had just a moment ago. Let me widen out here. Now I'm going to add a space here and then get rid of them just so you can see. This %s, I'm going to do a format string on this, okay? And this is what it does is it takes data in and inserts it into the form of the type of data that you specify. So with the format string, the %s says, hey, take the next parameter here and include this as text within this, right? It's almost like templating, but you can kind of think of it that way, but it's to make sure that the formats stay proper as we progress. Format. I'm going to get rid of these spaces because they're not necessary. And then I just need to give it what needs to be inserted at that %s. And in this case, it's going to be the payload. Or I'm sorry, the token. We're creating payload. Okay. So we've created the token. We're now inserting that token into the payload. Right. Now the data variable that we have right here, we still need to construct that. And so we're going to create another variable. Can you tell I'm used to using a more advanced IDE that does my tabs and everything for me? Data equals. Now, inside this data variable, we're going to do a string dot. Hold on a second. Looking at my notes, I did the wrong thing up here. Look at 2 different lines. String dot format. That in there, and then we're going to put the payload into that. That's why I was wanting to do payload there. Now up here, what this should have been was the command that we want to run or what we want to inject, right? So in this case, do a space, the pipe sign, we're going to do echo, and then %s. Right. And that %s is going to take the token that was generated in the token variable and insert that into this echo command, right, and then drop it into the payload here. Okay. Now we have the data variable, which is going to get passed right here, and that's the data portion of the post request. Right, it's showing up in like the body of the post. Right, we've set the scheme, we've set the header, right? This request is pretty much ready to fire, okay? Now, then the question is, how do we get the output from here into the output of our Nmap script? Right? So we very simply come back down, very much like what we did before. We're just going to return, right? It's going to basically in the script, put little gap here just so it's easier to spot it. Return std NSE dot format output. We'll do string dot match, and we're going to look at the response. And I'm just going to look at there's multiple, there's a table of information that comes back in the response. And so I'm going to pull out specific things. So I'm going to look at the raw body portion of the response. All right, and we're matching on that, and close that out. And what I want to look for is the token. All right. And so if the token is there, it'll then be printed out in and displayed below the name of the script when we run it here. Okay. All right, now I'm guessing there's a typo, there's a missing parentheses or something here when I hit go. We'll find out. If I did everything right, I'll be very surprised. But that'll give us the chance to show you how to debug some of these things. So I'm going to make sure it's saved. And do Nmap and do 2.168.0.101. Give it port 10,000. Script http / webmin check.nse. And fingers crossed, and it died. Now, when it spits this information out, it looks like a lot of information and it sounds like gobbledygook, but if you stop and read and look, you can usually figure out what the issue is. So as you look at this, it failed to initialize the script engine. Well, yep, I blew it up. How did I do that? Well, looking at line 31. Right. So let me display line numbers. Very good. All right, so I look at line 31, and what's going on? What are we missing? Let's read a little bit more. All right, and line 30. Okay. It didn't like either one of those lines. Now, what it's probably complaining about is both those lines are where I was doing string operations. Well, I forgot to include the string library up top. Now let's save that. Okay. And we'll run it again. And died again. Looks like a oh no, I think it's complaining about parentheses. I jumped to a conclusion too quickly. Yeah, so I didn't close out one of my parentheses here. I probably did the same thing down below.
There's a couple of comments here. Someone says line 31 is missing a closing. Line 31 missing a parentheses. Line 34 missing closing parentheses.
Probably it. All right. Now I've got an extra there, don't I? No. So that's good. 1, 2, 3. 1, 2, 3. And 35. Well, it did the exact same thing down here. All right, so it did run. But it did not run the script. Check whether function.
Someone says line 31 now has one too many parentheses. Actually, that comment might have been made, well, it looks like a minute ago.
31?
He says parentheses are okay now.
Okay. All right. Now, we're going to do some extra here. If you're having trouble debugging why something is not working like this, there's a debug option in Nmap. So we can add in, oops, didn't copy. I'm going to copy and paste this debug stuff just because there's multiple lines. I want to get this in here quickly. And what this is doing is using that std NSE library to do debug 1, so it's just debug level 1, and it's going to print out different portions of that response. Okay, so when I run with the -d, I'm actually going to see a whole lot of output for this. It's just going to give me more detail than it just didn't work, right? Hopefully we can figure out what's going on. I'm guessing there's something wrong with the response body or something like that. I've mistyped that or something. It's not even replace that whole thing with a paste. Connection refused. All right. All those fails. Those are to the pre-baked cake that's already in the oven. So copy and paste of my working test script. So let's check 2. Not sure why it's saying connection refused. No. Okay. So switch over to VS Code. This is local to my Mac. This is where I did most of the development for this. This is basically I just copy and paste it in there. If I run the same thing, so this is I called it info on this computer. It goes through, and then you can see it produces that that base 64 encoded text. So we can echo that to that's the hash. But that's what the ASCII hex would look like. But so it does work. I'm going to dig into what's going on with the inside here. For some reason, it doesn't like this host. Not exactly sure why. Data. I will open it up here for questions if you have any at the end.
All right, thanks. There are more comments about what you were working there. Do you want me to read those first?
Sure, maybe they can see what I'm missing.
Let's see, I'm going to check the time. Yes, line 30 has too many parentheses, too many closing parentheses. It only needs 2. Someone else says, do you have a -K on the Nmap to allow for beds? Oh, I don't think that's in relation to this. Sorry. Let's see here. Yeah, it's just that one suggestion.
Okay.
And then we've got other questions that I could move to when you're ready.
I believe it's the scheme issue. What if I miss? It's right here.
Someone says there seems to be an error with the string match parameters.
Well, if we look up here, you see trying URL. This is that error I was talking about where if you don't connect over SSL, it thinks it connected, but it didn't, right? So a web server is running SSL mode. And the way I fixed that before was with that scheme option. I'm wondering if, I believe this is Nmap 7.7, and I did my testing on 7.8, and see if it gives us the Lua version it's using. There's some changes and such that may affect it in the difference between, oh, this is Lua 5.3. I'll have to play with that. It'll be maybe a blog post for another day.
All right, we'll go ahead with the questions then. Will the final script be published?
Yes. I'm going to do a blog post about this and put it to the Sans Pentest blog. That'll be coming sometime later in the week, or actually it's got to go through an approval process after I write it, so I'm not sure when it'll actually post. But I'll do a blog post and I'll link to GitHub and such, so you can see that out there as well.
All right, thank you. I'm not sure if this relates to what you were working on or if it's a separate question. Does he have -K on the Nmap to allow for bad certs?
I don't think that will make a difference, but we'll try it. If it was -K is usually for like curl, and I don't think -K is a valid option for Nmap.
All right.
The -K allows you to accept invalid certs with curl. So.
All right. When you are troubleshooting a script, have you found different use cases for -V versus -D?
Verbose versus debug. Yeah, you can get different details about it. I'll also use the packet trace as well. So you get here. Let me get rid of do a -V. Oops. Got to get rid of that -K. All right. So you get a lot of the same information, but we're not getting the debug level information that we're getting about the script and that kind of thing.
All right, and since we're over time, I'll just do this last one. Do you use VS Code to edit scripts? If yes, what are your setup configuration extensions? Just Python?
I do use VS Code. For this stuff, you don't need Python. And the reason is that we're doing everything in Lua, right? So the Nmap Scripting Engine is running in the Lua programming language. So you just make sure you change the settings for VS Code so it recognizes .NSE as a Lua extension as well. There's more I need to do to make VS Code work better for me. There is a tool out there that helps to some degree with developing this stuff. Let me, oops. There's a tool called Halcyon. I don't use it a lot. I've had just, it's just okay. It's supposed to be an IDE just for the Nmap Scripting Engine, but it has little quirks that I'm not a big fan of. Like for instance, over here, we see all the Nmap scripts, but they're not alphabetized. I have no idea how they're ordered, but it makes it very difficult to find a script that you want. So if I want to look at, let's see, there's H shell shock, that's a good one. So I can double click that and then I can read that script. I can reference this, right? And I referenced a lot of different scripts to see how different scripts were using the HTTP functions and that kind of thing. And so you can read through, see how they're doing things. You can see there's no definite standard as to how all this stuff should be done, but you'll see a lot of good examples. One of the nice things about this tool, let me create a, let's create a new project. Yeah. So it'll create everything for you, right? So we'll just do it test.nse and just, that's fine, default's fine. You can see it kind of creates that skeleton for you, okay? And at this point, you begin editing from here. There's some snippets and that kind of stuff. So if I want to code generator, so if I want brute force, okay, so engine. So this is a brute forcing engine. So it's got some little snippets and stuff in there that are kind of nice. If I need that stuff, I'll usually just come in here, copy and paste that out into VS Code just because I'm more comfortable in code. And every once in a while I have had Halcyon die on me and not save my progress. So great tool, but it's not necessarily one that I'd recommend for hardcore development. It's cool for referencing and learning though. And then you can do this from here. You can just you click that to enable these options and hit run, and you can see the execution down below.
All right, well, thank you so much, John, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.